Okay, good day all. My name is Ebo Victoria, and I'll be taking you guys on chemistry. That is the subject. While the topic is acids, bases, and salts. Okay, why I deem it pertinent that we should look at this topic today is because this is a topic we come across all the time while trying to do things in chemistry. You must come across acid, base, and salts. Sometimes some students have issue trying to identify the one that is an acid or a compound that is an acid or a salt or a compound that is a base. That's why I want us to look at it today. First of foremost, I will be starting with the first one we have there, acids. Okay, I will give you the definition of acid before I go into explanation of that very concept that I'm going to define now. What is an acid? An acid is a substance which produces hydrogen ion when it is in solution. I repeat, it is a substance that produces hydrogen ion when it is in solution. We have modification in this very topic or in this very definition that I have said now. The modification comes from that word hydrogen ion. We can modify it to be hydroxonium ion. If you don't want to make use of the hydrogen ion, you can use hydroxonium ion, but they are not the same thing. At the course of the learning, I will try to differentiate between two of them. Okay, let me quickly put this down so that you can understand what I am trying to explain. An acid, hydrogen ion, hydrogenium ion. We have various types of acid. Let me start from there so that you can be able to understand better what I am trying to explain. Okay, let's look at it. I made mention of we have various types of acid. Types, I've given you the definition. Types of acid. I just example of them. That is what I am trying to give you now. Sorry. So that I can be able to go back and explain better that very concept that I gave to you. I say it is a compound that produces hydrogen ion when it is in what? In solution. Okay, let's look at it now. Example, I have HCl. What do we call this HCl? Hydrochloric acid. It's an example of an acid. H2XO4. What is the IUPAC name? This is hydrochloric acid, and this is hydrogen tetraoxo sulfate 6 acid. Hydrogen tetraoxo sulfate 6 acid, otherwise known as sulfuric acid. It's an example of what? Acid. We have HNO3. Hydrogen trioxo nitrate 5 acid. This is also an example of what? An acid. Let me go back. Remember, let me put this down so that you will not be confused to where I am heading to. I say an acid is a substance which produces hydrogen ion as the only positive ion when it is in a solution. Okay, this is the key word, hydrogen ion. That is what I am trying to point out so that you will understand what do we mean by hydrogen ion and how is it produced, so that when you see an acid, you can easily identify that this is what? An acid. Let's take, for instance, the first one. This is hydrochloric acid. This is hydrogen tetraoxo sulfate 6 acid. When what we call in chemistry ionization or dissociation takes place, that is when this hydrogen ion can be what? Produced. Let's pick the first one so that we can be able to know what it is all about or know it better. This is hydrochloric acid. When dissociation comes in, it will give me hydrogen ion plus chlorine ion. Remember, don't forget that hydrochloric acid comes as a result of what we call chemical combination, electrovalent chemical combination. Okay, let me explain in detail so that you can get what I mean. All right, remember, we have two types of chemical combination, two main types. We have electrovalent chemical combination and covalent chemical combination. Looking at this very compound, it comes as a result of electrovalent chemical combination. Hydrogen is trying to behave like the noble gases, and chlorine as well is trying to behave like the noble gases by coming together to meet with that is each other. Hydrogen coming to meet with this and chlorine coming to meet with this. Let me explain better here. Using our KLMN electronic configuration, we can do it this way. Okay. I have, this is my nucleus. This is the first shell is entitled to have 2 electrons. 1, 2. While the second one is entitled to have 8. See how I'm going about it. I have 1, 2, 3, 4. That is 1, 2, 3, 4, 5, 6. Okay, I continue. 7, 8, 9, 10. Remember, the element I'm trying to represent here is what? Chlorine. I'm trying to show us the combination, how it comes and how it's split into forming an ion. Remember, hydrogen ion, which is what we are actually looking at in definition of an RC. Okay, this is first shell, second shell. Because chlorine is number 17, I believe we know our, let me start with the first 20 elements because we have many elements in chemistry, but at least you should know the first 20 what elements. Chlorine being number 17, I have 10 represented already with a what? A star or asterisk as my electron. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means I am left with what? 7. I draw it this way again. We go 1, see how I'm going. 2, 3, 4. I want to draw 7. That is to make up this 17 because I have 10 already. 1, 2, 3, 4, 5, 6, 7. What have I done? I have tried to represent this 17 of chlorine here in each word, electron, in each shell. This is first shell, second shell, and this is what? The third shell. Okay, you know, one of the things we consider is why is it that this chlorine is going into what? Combination. Because this very electron is not complete. Am I communicating? Okay. It's just one that is remaining. Then hydrogen is number 1 element, which is having just one word, electron. But remember, the fourth shell is entitled to carry how many? 2 electrons. And as you can see, the fourth shell here is having just what? 1. Whereas here, which is the third shell, for that of chlorine, is in need of what? 1. So what they will do is to come together to form what we call what? Electrovalent bond or electrovalent what? Compound. pound. All right. Remember, hydrogen is the one having one. It can easily transfer this very electron to this place, which is in need of what? One. What have I done so far? I can now represent it this way. 1, 2. I'm talking about the product. 3, 4, 5, 6, 7, 8, 9, 10. Okay. The third shell now, we are going this way. 1, 2, 3, 4, 5, 6, 7, 8. Why am I having it as 8? Because I have carried this very electron to chlorine here, making it what? Stable. The reason why they go into this chemical combination is because they want to behave like the what? The noble gases. I believe we've heard about the various classification of our elements based on their common properties and all that, which leads to groups and the what? Period. We have our group 1, the alkali metal, group 2, alkaline earth metal, though that is not where we are going to. But what brought about this is my explanation, or what I'm trying to explain under these what? Noble gases. As you can see, hydrogen has easily thrown or released its one electron to chlorine, making this now what? 8 is complete and as well what? Stable. Whereas for hydrogen, there is nothing disturbing it. They form together, please. In case if you see it in your textbook, it will come this way. Are you with me? It comes together. Okay. Now, when there will be splitting, this is chlorine and this is hydrogen. Coming together, we call it hydrogen chloride. When there will be splitting on this will now turn to chlorine what? Ion. And this will be what? Hydrogen ion. Why? Because hydrogen has released its what? Electron. Remember, in chemistry, when an element releases its electron, it turns to what? An ion. Not just an ion. It turns to what? Cation. That is, it's having what? Positive what? Charge. While the one that is collecting it will go with what? Negative. All right. So back to my definition on this, which is what? Acid. A substance which produces hydrogen ion as the only positive ion when it is in what? A solution. Look at what I have done now. I have splitted it from there. Okay, so this is now hydrogen ion and this is chlorine ion. I believe by now, when you are asked what an ion is, you should be able to tell that it is an atom that is having what? Charge. This is it. I have shown you how it was first combined and the splitting. If splitting takes place, it turns to what? An ion. This is hydrogen ion and this is what? Chlorine ion. Okay, there was something I said when I was giving us the definition. The same thing can happen here if I want to split it and do more example on this. Don't say I'm using just one element or one compound, sorry, to illustrate. We can as well use this H2SO4, which is hydrogen tetraoxo sulfate 6. If ionization takes place or dissociation takes place, this is what we are going to have. Hydrogen ion, 2 coming here, plus a radical. That radical will now be what? Tetraoxo sulfate. Tetraoxo sulfate. I hope we've gotten that. Okay. Now, I'm done with this first definition, and I believe we have learned what an acid is based on this very first word definition. A substance which produces hydrogen ion as the only positive word ion when it is in a solution. All right, I want to take up this and take us to the second definition because I said when I was starting that we have modification on the definition of acid. Okay, say it's oxo, a substance that produces hydroxonium ion. The first one, take note, hydrogen ion, which is this hydrogen ion. Second one, hydrozonium ion. Hydrozonium ion. Okay, this is gotten from, you can react an acid with water to give you what? Hydrozonium what? Ion. Okay, let me explain. For instance, if I have hydrochloric acid plus H2O, you know this is molecule of what? Water. And this is what? Hydrogen chloride. If I react the two together, I am going to have this. O positive. Are you with me? So, plus chlorine what? Ion. Hydrogen chloride, this water, molecule of water, and I'm producing what? Hydrozonium what? Ion, and what? Chlorine ion. I believe now I've established that fact, which is what? What an acid is. Is either you go with this or you go with this. One of the problems that the students normally complain about is that they don't know, is this one an acid or is it a base or is this a salt? Take note of these very points that I have emphasized on, which is hydrogen ion and hydroxonium what? Ion. That means when I am not seeing this in a compound, definitely that compound is not what? An acid. All right. Sometimes one of the problem again that the students do have is trying to name the compound, very well. Like I have H2XO4. Why am I calling this hydrogen tetraoxo sulfate 6? Am I doing magic? No. Remember, these are elements that we've joined together to form a what? A compound. In case if you are asked to mention names of what? Acid. How do I go about this? I just want to teach you, maybe you've learned or you are just learning it now, but just take note so that you can be able to name your compounds. It's very important. An example, hydrogen tetraoxo sulfate 6. An example again, here is hydrogen triazole nitrate what? 5. If you're asked to mention your acid, though I will still enter into types of acid and how to identify them, but I am talking about the naming using IUPAC. Okay, for us to name our compound, there are things we put into consideration. Look at it. I have hydrogen here. After my hydrogen, I am taking the number there, which is what? 4, as what? Tetra. Oxygen here is no longer what? Oxygen. Rather, I refer to it as what? Ozo. And this is what? Sulfur, which I am now regarding as what? Sulfate. Okay, let's look at it. One thing you must know for you to be able to name your compound very well is what we call oxidation what? Number. Please, as you are learning your chemistry, always take note of this very thing I am talking about now. Atomic number, atomic masses, and oxidation number. Because these are things that will help you to be able to do what? Name your compounds, both in chemistry. Okay, most especially in chemistry subjects. All right, let me continue. For hydrogen, hydrogen is having oxidation number of 1. So I will do 1 times 2. Why am I saying 1 times 2? Because of this 2 that is coming as a subscript. This one, sulfur, is what I am looking for. I don't know it. I can represent it or designate it as what? X. Then plus Oxygen is having oxidation state or oxidation number of minus what? 2. I will do minus 2. Minus 2 times 4. The rule says equate it to 0. It's a separate topic you can learn under chemistry. But why I'm bringing it is so that you'll be able to name some of your acid. Some students, it marvels me that we don't know how to name our compounds. Okay, we have till. This is 1 times 2 plus x. That is my unknown. Let me open the bracket. It will now be minus what? 8. Minus 2 times 4 is now minus what? 8. So minus times positive is what? Minus. So I'm having minus 8 is equal to what? 0. Why am I equating it to 0? Remember what I said. It comes from the rule. The rule says when you are not having a charge attached to the compound, you do what? You equate it to 0. But let's assume I am having a charge attached to it. That is when I cannot equate it to the what? Charge number. If I am having something like this, for instance, that means I'm equating to 1. If I am having something like this, 2 plus, that means I'm equating to 2, but it's not in this what? Compound. Reason why I'm saying it is in case you say it's X-ray. Okay, at this very point, I'm going to what? Collect my like terms. Okay, this is X is equals to collecting like time. This is crossing over. So now be what? 8 minus what? 2. X is equals to 6. That is 8 minus 2 is equals to what? 6. If I want to name this compound now, I will say it's hydrogen tetraozo sulfate. I will not pick the oxidation number. 6. The same thing is applicable here. That is the last example I will do in naming of this our acids so that I can now move over to the next subtopic. Okay, this is hydrogen triosonitrate 5. Why am I calling it 5? Take note of one thing that I'm doing here. When I call the first element, I pick up this, the number. Because 4 is here, I name it as what? Tetra. 3 is here, I am calling it tri. Let's assume it's 5. You know that is when your pent comes in. Remember, 1 is mono, 2 is di, 3 tri, 4 tetra, 5 pent, 6 hex, 7 hex, 8 oct, 9 non, and 10 what? Dec. So that's by the way. Coming back to where I am, or where I was, sorry. This is hydrogen having oxidation number of what? 1. I'll write it. Is there any subscript here? No. Remember, the first one I did is this. Because I am having subscript, I did 1 times what? 2. Plus. My nitrogen is what I am looking for, just like this very one. X. Plus. That same thing we did with what? Oxygen. What am I going to do now? I will do minus 2 times what? 3. Minus 2 times 3, you should know is minus what? 6. Still equate it to what? 0. At this point, I want to open the brackets with 1 plus x minus 6 equals to what? 0. Collecting like terms, I am having my x is equals to minus 6 crossing over to the what? Positive 6. Then positive 1 crossing over minus what? 1. I am now having it as x is equals to what? 5. To name it now, I am naming it again. Hydrogen triosonitrate 5. The first one, hydrogen tetraozo sulfate 6. I believe by now you can name your compound using these steps if you can be able to do it very well. All right, back to what we were talking about, which is our acid, because we are still on it. I just gave you the definition and established some facts there. Hydrogen ion and hydrozonium ion. Now I want to move down to types of acids. We have the first one as what? Organic acids. And we have the second one as inorganic acids. Okay, organic. Whenever we hear organic, our mind should go direct or straight to what? Natural. There are some acids that are there in nature. It did not undergo any laboratory work or preparation in order for it to come what? On board. Okay, let's start with the first one, which is organic acid. I'm going to give you examples of it. I have, let's say, ascorbic acid. That is the one we normally get from our vitamin C, usually from oranges. Okay, it's an example of what? An acid. That's why sometimes when you take unripe orange, you do what? Slaps. It's because it contains an organic acid. Okay, another example here is your citric acid. Your citric acid comes from lime. Another example here is your amino acid. Amino acid comes from end product of a protein. Don't forget, that protein you are taking is amino acid. That is the end product of it. That is the food that contains protein as its what? Nutritional value. Okay, that's, by the way, I've given you 3 examples under organic what? Acids. Now I am going over to inorganic what? Acid. Inorganic acid, we refer to those one as mineral what? Acid. If you don't want to call them what? Organic, inorganic acid. You refer to them as mineral. I have H2XO4, which we just play with now, hydrogen tetraoxide 6, HCl, hydrochloric acid. Which other one do we have? HNO3, hydrogen triosonitrate 5. All these are examples of what? Inorganic what? Acid. Okay, now under the types of acid, we can look at it as organic acids and inorganic acid, or strong and weak acids. Strong and weak acid. I'm no longer talking about this. So let me bring this one close so that we can understand better. Strong and weak acid. Okay. When you are talking about strong acid, these are acid that ionizes completely in what? In water. When we say ionizes completely in water, that means all the replaceable hydrogen ion have established the fact of hydrogen ion, what it means in the course of this study. All the replaceable hydrogen ion in this strong acid will what? Be removed or will dissociate. Are you with me? Why this very one, which is weak acid, the replaceable hydrogen ion will not be what? Replaced. It ionizes partially. That is what we mean. Here, it ionizes completely. Let's take, for instance, HCl. When ionization comes in, or when ionization takes place here, I am going to have hydrogen ion and chlorine what? Ion. There is nothing like there is still hydrogen ion on this. Everything is now what? Separated. I have 2xO4. Remember, I am giving you examples of what? Strong acid. And one thing I have said about it is that all the hydrogen ion do what? Separate, or they ionize what? Completely. When I will do example on this, you will understand what I mean by being ionizing completely and some not being ionized, that is partially. Okay. For this now, I am having 2H plus. Why 2H plus? Hydrogen now here is what? 2, right? Trying to balance the equation. That's why 2 comes in here and it's now an ion, showing you the charge. Plus XO4 2 minus. It comes as what? A radical. If you look at this equation, all the hydrogen ion are on the same place. The same thing is happening here. Whereas if it is a weak acid, here the ionization will not be what? Complete. Are you with me? Let's say, for instance, we have CH3COOH. This is a metanoic what? Acid coming from what? An organic compound. Remember, this is an organic what? Acid. Okay. When this association comes here, you are not going to have what? Full splitting or breaking of the hydrogen what? Ion. Rather, you will have something like this. Your hydrogen what? Ion plus CH3 COOH. Are you with me? The ionization is not taking place completely. Okay, look at it here. Let me write the first one. HCl, ionizing. I am now having H plus chlorine plus negative, sorry. Hydrogen ion, chlorine ion, everything has separated. The same thing happened here. Sorry, look at this one, is not happening that way. CH3, COOH. This is metanoic what? Acid. I am having just one hydrogen ion when dissociation wants to take place. And I am having this here. I still have my hydrogen ion on this very what? Compound. I don't know if I have communicated. Here, ionization takes place fully, while here there is partial what? Ionization. I believe when you see strong acid, you should be able to identify it, or weak acid, you should be able to identify it. We have other examples. I've given you metanoic acid as an example of weak acid. We have other example like tetraozophosphate 5 is also tetraozophosphate 5 is also an example of weak acid. Ionization of this can never and will never be what? Complete. Okay. Another example is hydrogen triosocarbonate 5. Hydrogen triosocarbonate 5 is an example of weak what? Acid. At least I've given up to 3 for that of organic, for that of strong, and that of what? Weak. So let's take note of that. Okay. The next place I am entering now is on the basicity of an acid. Basicity of an acid. When you are looking at basicity of an acid, remember we talk about the definition, types of it, example, how to name them. We are not going over to basicity of what? An acid. We have 3 main types: monobasic, dibasic, and tribasic. Just like what I've given us before, we have 1 as mono, 2 as di, and 3 as what? Tri. Monobasic, dibasic, and the what? Tribasic. That means here is having 1 hydrogen what? Ion. Here, dibasic, 2 what? Hydrogen what? Ion. Here, tribasic. It has what? 3 what? Hydrogen what? Ion. But sometimes some students get confused based on the what? Number. Because there are some of the elements that might be having what? 3 as their what? Hydrogen what? Ion. But they don't fall under what? Tribasic. Okay. So look at this. Let me explain this better so that you can be able to do what? Understand it better. This is HCl. When dissociation takes place, I am having H positive, that's hydrogen ion, and C what? Negative, which is chlorine what? Ion. What has happened? When dissociation takes place, I am having just one what? Hydrogen ion. And this one now, just one what? Chlorine ion. Let's look at the second example. We have H2SO4, for instance. If dissociation takes place, I will have 2H positive and my words SO4 as a radical. Okay, as you can see, this is just one hydrogen ion, and here is what? 2 hydrogen ion, making this a monobasic dibasic. In the course of our next lecture, we are going to talk more about acid because we still have many things to say on this very topic. We've not talked about its properties. You should note that we have physical and chemical properties. We as well have the uses, their laboratory preparation and all that. But for now, we are going to draw the curtain here. Thank you.